Okay, just going to talk you through the inert pair effect. Now we're going to look at carbon. Carbon has 6 electrons, so that would be 1, S, 2, 2, S, 2, 2, P, 2. Okay, now what we think we'd normally have in this case is, let's say this is our 2S, and our 2P, which is slightly higher in energy level. So you end up with this. This would result in an oxidation state of 2, because you want to oppose these two unpaired electrons. Sorry, these two electrons that are spinning upwards. You need something to counteract that charge. But what you actually get is carbon bonds 4 times, and that's because the various orbitals hybridize. They gain the same energy. They drop down, or this goes up a little bit, and this one comes down. They get exactly the same, and you end up with this promotion. 1. So you end up with 1, 2, 3. Now it bonds 4 times. Okay, this is all about the inert pair effect. Now, when you're talking about carbon, which is what I was looking at, if you had small atoms, the inert pair effect is kind of the opposite of this. This is where it's happened. The inert pair effect is where it doesn't happen, because you've got these inert pairs. And the reason why it does happen is that small atoms, when they bond, there's a lot of energy kicking around, and it allows this to happen. But with things like lead, which has got loads and loads of orbitals, the electron over there doesn't give it enough energy to cause this hybridization, so you get something called the inert pair effect, which is why lead has an oxidation state normally of 2 plus 2, where carbon has an oxidation state of 4. But the confusing part is that the inert pair effect is what causes lead, the big atoms, to have the lower number oxidation state, and the opposite. The inert pair effect doesn't happen to carbon. It does do this promotion and create the hybridization. This is all on page 29 of the textbook as well. Thanks.